Hello, everyone. My name is Vijay. Welcome to this session on analyzing transactional data in Apache Druid. Okay, you can see my PowerPoint slideshow. So just briefly about myself, I'm currently a solution engineer with Imply. Before this, I've been with Cloudera, Hortonworks, Cloudera, and then before that with Pentaho. I'm based in Bangalore, India, and relatively new to open source. Been in open source for the last 5 years, but I have a total of about 18 years experience in the data integration and analytics area. So this session will spend the first about 5 to 10 minutes on introducing Apache Druid as a platform for big data analytics. Then talk about what is transactional data in the context of this session. Talk about challenges in analyzing the transactional data in Druid, lay out a couple of approaches, and also then focus on the benefits that are to be had in analyzing transactional data in Druid. Druid was invented to address a very specific problem, that there is no optimized real-time data store for analyzing data in real time, and also analyzing data that is very fresh. So Druid combines a number of different concepts and technologies. First is real-time streaming analytics, multidimensional OLAP, combined with the scale-out storage and computing principles of Hadoop. The shared nothing distributed architecture and the ability to scale based on the size of the data and the number of queries that are coming through. So Druid sits at the intersection of a number of areas. One is the ability to do search, ad hoc queries based on indexed data, time series queries, and pretty much queries that give you sub-second end-to-end response time. So Druid basically sits at the intersection of OLAPs, time series database, and search engines. If you think of the digital consumer today, there are a number of characteristics that are driving the need for extremely real-time analytics, which is also usable by all personas. Right? So first is the digital consumer. As a digital consumer, I know that my world creates a lot of data. I have lots of applications of different devices, and all of them are constantly creating data, and I need to be able to analyze that data. Now, as a buyer of products, I of course also know that if one online store does not satisfy my requirements, does not have what I want, I can always right away jump over to another store. So the ability to know the customer's requirements and satisfy them in real time is quite critical. And of course, the consumer is pretty aware. Everybody these days know that data is very powerful, and any limitations on how I use my data can lead to all kinds of interesting concerns, including about liberty, about privacy, and stuff like that. And lastly, as a consumer of data, I want to use data in a very in newer and more instinctive ways to make decisions. And I want to be able to use data that is coming in today, look at data that's there in the past, look at patterns from the past, see the patterns from today, and so on. So all these things lead to some interesting requirements for a tool that aims to allow consumers, data consumers, to work in this new world of data. First is, data consumers need the complete picture. This essentially refers to scale, where we need to be able to analyze petabytes of data with large amount of concurrency so that all users can look at the data from their own perspective. And data needs to be refreshed frequently. It needs to flow in fast, often terabytes per day. users are looking for a conversational experience. What that means is that I don't want to run a query and go away and have a cup of coffee and come back. I would like to do things in such a way that I run a query, I get an immediate response, and based on that, I run another query and so on. So we need an interactive conversational experience with the data. I also don't want lots of pre-built dashboards which sort of restrict my view of the data. I would like to analyze the data in a very ad hoc manner and do arbitrary slicing and dicing. So I need data at great granularity. There is no point having a lot of pre-aggregated data, because what aggregate I need, I won't know until I begin the analysis. And I want a user interface that is very responsive. So all these requirements translate into some key technical concepts. I want real-time event-based platform, which actually is very relevant for our current problem of analyzing transactional data. As we will see, transactions are simply made up of multiple events, and a platform that stores events in time has certain unique challenges in analyzing that kind of data. I want a platform that can deal with large volumes of valuable data. A platform that ingests primarily cleansed, enriched, joined, and normalized data. Data that has multiple dimensions. And lastly, the ability to create different types of metrics with different types of statistics. Druid is a platform that has been built in keeping all these requirements in mind. So Druid is used by consumers through many different means. Consumers who want to make decisions based on descriptive analytics, on statistics, use tools like implied pivot, looker, tableau, superset, and so on. Consumers who want to put together their own UI, have a custom front-end experience for their customers. They want to, they use tools, frameworks like React or Angular, and so on. And lastly, there are data scientists who would like to use a platform like Druid, primarily because, often generating training data from a petabyte scale warehouse is very difficult and very time consuming. So often data scientists find that, with the data lake on one side and with the customer on the other, they are constrained in actual machine learning they can do, because it's taking a long time to fetch the data from the lake and feed the models. So Druid will also help in that. So Druid brings two things together, business intelligence and real-time intelligence. You can see some of the differences here. Business intelligence is about function-based analytics, while real-time intelligence is more performance-focused. How soon can I do things? Business intelligence usually uses tools that are for analysts to use, while real-time intelligence tries to democratize this so that and make consumption tools available to the entire organization. With business intelligence, you're often trying to answer what is happening now. With real-time intelligence, you would like to know what has happened in the past, and also what is happening in the recent past and almost up to now, right? And with real-time intelligence, you want to have, often it is information is served on a schedule, while business intelligence is, trying to do ad hoc things with the data. Right? So these are some of the differences between real-time intelligence and business intelligence, and Druid sits at the conjunction of these two capabilities and concepts. Business intelligence, which usually traditionally depended on data lakes, data warehouses, Hive, for example, or even going back, your Netizas and Verticas and legacy systems, data lakes like your blob stores, and then event hub. So Druid sits in this conjunction of real-time and business intelligence. The mission of Druid is to make data more accessible to more audiences. So traditionally, analysts ran reports and answered questions from business guys. But with a platform like Druid, it's much more easier to allow the business guys to start using the data directly instead of depending on a team of analysts. The speed of querying in Druid allows users to sort of focus on their curiosity rather than just focusing on a template analytics. This is absolutely important to get what I would think of as serendipitous insights. So insights that happen by accident. And Druid allows combining real-time and historical data. This allows us to tell the whole story, and finally get new data to decision makers faster. So if my CEO is sitting and looking at a dashboard or a report, and it is taking minutes or even seconds to load, that's not a good state of things. You want all that to happen sub-second, and that's what Druid is very good at. So Druid brings about the ability to democratize analytics and to accelerate adaptation of an organization to changing circumstances which are revealed in changing patterns in the data. Okay, so where does Druid fit in the broader pipeline, data processing pipeline? So if you think of the pipeline as something where data is produced at an application, it is delivered using some tools like Amazon Kinesis or Apache Kafka, brought and processed in things like Spark or Hive, and then stored in a variety of systems, HDFS, MySQL, HBase, and so on, and finally queried and then delivered. The querying is where Druid fits in. Querying is all about slicing and dicing the data, doing ad hoc metrics, using ad hoc statistical calculations. This is where Druid fits into the whole pipeline. Okay, so this is a brief overview of the Druid architecture. So I'm not going to drill into Druid architecture in this session. There have been other sessions in this track focused on some of the aspects of Druid architecture. Druid has a typical distributed big data architecture with master nodes, data nodes, and query nodes. Data nodes store data in a partitioned fashion, primarily partitioned by time, but it can be partitioned by other dimensions also. And the data is also indexed, bitmap index, string fields a bitmap index, so that searches are very fast. And some of the data can be in memory, and some of the data can be in disk. So Druid uses memory mapped files to handle the data that is on which queries are being run. So depending on what data is going to be used by a particular query, it can get paged in and out of memory depending on how much memory is available. Now, the query nodes in Druid actually bring in the queries and choose which data nodes the queries will go to depending on the time period in the query. And they also support various interfaces like SQL, JDBC, REST API, and so on. The master nodes coordinate the whole thing. They manage the multiple tasks that are ingesting data either from real-time streams like Kafka or from batch sources like HDFS, blob storage, and so on. And they also manage the task of distributing the data in the data nodes so that queries are balanced out and query performance is optimal. And there is a metadata database that stores usually MySQL or Postgres, which actually stores the metadata about the data that is sitting in the data node. And all this is coordinated by Zookeeper. This architecture is highly optimized, and the format in which data is written in Druid is highly optimized for query execution. And this is one of the primary reasons why Druid is so high performant in query execution. The key thing to note in this architecture is that data that is once written into Druid is immutable. There is no updating of data. Although some data can be deleted, that process is not as simple as in other systems where you can just run a delete query in SQL. With Druid, that's not as simple. So updating data is not supported. Data that is written into Druid tends to be immutable. So this takes us to the question of what is transactional data and what are the issues around handling it in Druid, and what are the benefits that you can get by storing transactional data in Druid. Now, the way I think about transactional data is data that actually changes around the primary key. So it could be customers who go through various stages on my website, or it could be a user who's visiting my website and visits a number of different pages, Or it could be payment data where, payments are first created, payments are completed, and sometimes even canceled, because with the modern, with online retail, often when so customers choose to return something they purchased, then the payment gets cancelled or refunded. So payments can go through multiple stages in this world. So data that has updates happening around the primary key, or data that is sessionized, with a session starting at one point and session going, and the data going through various stages within the session and the session finishing. Right? So these are the kinds of data that I think of as transactional in this context of this session. Okay, so this is an example of transactional data from a online payments type of use case, where you have data that is coming in time. Each record has a transaction ID, which is essentially the primary key as far as this data is concerned. And it goes through a number, and all the other columns go through a number of changes. For example, status can be pre-created, paid, and then canceled. Like when a user makes a payment and decides to return that whatever they purchased, and hence the payment gets either canceled or refunded. And then there can be reason for canceling. And then there are methods of payment, and you could have a channel of payment and also the amount of payment. So this is a typical transactional data in retail finance, online retail finance type of situation. And in general, in traditional systems, this would have collapsed into this, because traditional systems would update the data based on a primary key, so that at any point, a particular transaction ID has essentially one record. Now, the same type of pattern also shows up, for example, in this case, some kind of a fitness application, which is tracking, when a person starts walking, it is actually tracking the distance and also the stages, for example, getting ready to walk, about to walk, walking, finishing walking, and done. So this potentially could be stages that a user goes through, and each stage is an event, and all the events are being captured. Again, in traditional systems, you would end up with one final record for that user, which gives you the final, or at least the current status of that user, depending on what time the data is being looked at, right? So the challenge in Druid is that this approach of updating based on some primary key is not possible in Druid, because Druid does not support updates and Druid does not have a primary key. Right? So in traditional systems, each primary key will have only one row at any given time. So you can query, for example, if you have to query for a transaction where status equal to paid, it will give you all the transactions that are currently in status equal to paid. But because Druid does not actually support updates on primary keys, this is not possible in Druid. And what happens when you look for transaction status equal to paid, it will also get you transactions where the customer moved from paid to cancel, right? So it will get you those transactions where that status exists somewhere in the transaction history, not necessarily the current status of the transaction. Right, so because Druid is an event system, it captures events, and obviously events are happening in time, and it captures all the events, documenting essentially the entire journey of that entity, whether it be a customer or a transaction or just an event. It documents the entire journey of that entity. Now, how do we deal with this kind of data in Druid? So again, traditionally, systems could have two kind of tables, say transaction and then transaction history, and then join it when the query is done. Again, doing that is not possible in Druid, because with Druid, the idea is you don't use a lot of joins. Joins are, definitely affect performance in all systems, and hence Druid does not support an extensive set of joins. So doing joins is not a very good option if you want to get query results in less than 1 second. So there are two ways of dealing with this in Druid. One is to use this latest, earliest, and any value SQL constructs. So these are some interesting SQL constructs that Druid, it's probably unique to Druid. For example, latest gets you the latest value of column by time. So if you take this data and look at this, this query, where I'm selecting the transaction ID and the latest status, And I'm also grouping by the transaction ID. So the latest actually treats that string field as an aggregate, and it essentially sorts that field and gets you the latest value by time. So if I were to run this query on this data I'm showing here, then pretty much I will get this, where for the transaction ID 1, I will get the latest status, which is obviously paid. For transaction ID 2, I will get the latest status, which is canceled. And transaction ID 3 has got only one status, which is created. Right, so it gets you the latest status in time for that particular event. In a similar way, you could deal with any any of the dimensions, the attributes in this way. It is applicable to all columns in the table. It's applicable to numeric columns and string columns. It deals with the earliest or the latest, essentially in aggregate, where the data is sorted and you get the latest or the earliest depending on what the SQL construct is. And of course, you can also use any value if there are, for example, the amount doesn't change. So I could use any value on the amount here. Channel doesn't change. So pretty much any value can be used for those columns where your value is not changing. Right? So this is kind of how one mechanism. So using this approach, what you can do is you can write a query like this to get the latest status. And then you can then count that number of transactions where the latest status is essentially equal to paid. So you can see I'm using a group by query, and the filter is being done on the aggregate by using this the having keyword, which allows us to filter on the aggregate values, and this will give me all the transactions which have the latest status as paid. Right, so this is one mechanism of handling this kind of data in Druid, which is fairly reasonably performant compared to other approaches using some kind of join or trying to do self-join with the same table. Those approaches tend to really ruin performance, but this approach is fairly high performant. Another mechanism which is often more effective from a performance perspective is using a Kafka lookup. So in Druid, a lookup is a concept where using a key, we can do a lookup against a key value. A table contains keys and values, and that would essentially return the value for that key. Right. So this allows us to allows us to have the latest time for each transaction in Kafka. Do a lookup on that, so that you can retrieve the latest time for each transaction and use that to filter the primary table, and that will essentially give us what we need. Essentially running a query like this, where I'm filtering here, doing a lookup on the transaction ID, which will get me the latest time for that transaction, and then I'm using that to filter on the primary table, so that I can retrieve only those transactions where which are for the latest time for that transaction ID. Now, this query may not actually directly run on Druid because it may require some additional formatting, since the lookup will have a time in string field, while the underlying time field in Druid is a timestamp, epoch time, millisecond timestamp. So that there's some additional formatting required. But the concept is that we use a lookup to essentially get the latest time. So when you're populating, when I'm populating data from Kafka into Druid, I will have two topics. One is the primary topic where I get all my data. The other one is just a Kafka lookup topic where I will get only the current time for each transaction. And this allows me to essentially, get the latest. And if I need the earliest, of course, I can also use another Kafka lookup with the first time for each transaction and so on. This is extremely high performant in with reasonable size data sets. With this kind of approach, it's very easy to reach a performance time of less than a second. And a few other thoughts on lookups in Druid. Lookups in Druid are extremely high performant. The Druid engine is optimized, highly optimized to use lookups for queries. And lookups are stored in all the data nodes and also the query nodes in Druid, and thus there is no runtime broadcasting of the lookup. And this is the reason why lookups perform extremely well in Druid. And lookups are stored both on heap and also as memory map files. So the size of the lookup is not restricted, and you can use fairly large size lookup to handle many use cases. Now that we have seen what are the ways of handling what I would think of as traditional analytics on transactional data in Druid, what more can you do with transactional data or event data or sessionized data if you come to think of Druid? One approach is to use funnel analytics to understand how users are transitioning from one stage to another. Now, in Druid, funnel analytics for scenarios where the funnel stages are pretty much fixed and users cannot go from, say, A to C and then come back to B. Right? Druid does not support that kind of funnel where the user's stage can arbitrarily change. The primary way of looking at funnels in Druid is a fixed transition. I come to A, now I can only go to B, and I can only go to C from there, and I can only go to D from there as a user. And this is often true in many use cases where the user, especially in financial payment applications, for example, payment app or use cases like that, where the stages the customer goes through are fixed. Now, there are other use cases where the stages are not fixed, like generally having a website where the user can browse anything they want, where the stages are really not fixed, and it's difficult to use this kind of approach in those cases. This primarily applies to scenarios where the stages are fixed. So if you think of a data like this, where the user actually goes through one or all the stages, as I've given here, user 1 goes through A, B, C in sequence, user 2 is just on A, user 3 is gone through, again, A, B, C in sequence, and user 4 is just on C. Now, of course, in this particular example, the users are able to, although this example kind of gives you stages where the users are going through different stages, the order cannot be switched. As I said earlier, they could come directly to B or C, but they cannot switch the order. That's the whole point of this approach. Now, the requirement often is to find out the set of users, count of the set of users who went through all two stages, like A intersection B intersection C, or just A intersection B, or B intersection C, or A intersection C. This is very useful in in understanding user behavior and essentially marketing to users. So, for example, if you think of an online OTT type platform, you are interested in noting which user watched series A versus series B of a particular program, or program in one language versus another language. There, the ordering doesn't matter. What matters is the user watching both those or any number of those programs or series, so that you can decide on things like what is the market size for all these things together. And then also try to target marketing in different geographies based on the audience preferences. So that's where this sort of analytics is very useful, where the sequence in which the users went through things is not important, is not critical. Okay, so this kind of analytics can be done using what are called data sketches in Druid. So I've given you a query here where I'm doing an intersection. So I have user going through. So first, there is the inner query where I'm selecting users where state is A, computing a theta sketch. State is B, again computing a theta sketch, and state is C, computing another theta sketch. And then on the higher level query, I'm doing an intersect of all these three theta sketches, and that will give me A intersection B intersection C. This using theta sketches with this kind of analytics is pretty much the only way of doing this in real time. So were I to use a brute force SQL query to actually compute this count in real time, the performance really will not be good enough to actually do it in real time. Okay, so to summarize, transaction data is kind of data that changes continuously for a primary key. So you can think of it as transaction data, sessionized data, event data. So a number of ways of number of terms to be used for that. Now, because Druid stores each change rather than just the final state, doing traditional analytics in Druid on this kind of data is complicated and can be done using a couple of approaches which are laid out in this presentation. use the latest, earliest, and any value SQL constructs. And also, the second approach is using a Kafka lookup to capture the latest time for a session or a transaction and use that to filter out the primary table. Now, because Druid actually stores all events, it opens the field for lots of different interesting analytics. This particular session talked about how you can use data sketches to do the intersection of the stages a user passes through on their way to the to their final journey with that application. So I hope this session was useful and give you some ideas on how you can use Druid. Thank you, and I am open to any question.